Hello everyone. In this video, we are going to solve some problems related to the deadlock avoidance. This is the problem that we are going to solve at first, which has 5 processes P0 to P4 and 4 resources A, B, C and D. This matrix gives the information about the allocation of resources to the various processes and the maximum number of resources required by the processes. After the allocation, the remaining resources available. So this is the information given, and all what we have to do is we need to find out the content of the matrix, need matrix, and we are going to check whether the system is in safe state or not using the safety algorithm. And the C question is, if the request from the process P1 arrives for 0, 4, 2, 0, can the request be granted immediately? So for solving the third question, we need to use resource request algorithm. The first step to solve the problem is to compute the need matrix. The formula to compute the need matrix is maximum minus allocation is the formula. So here, let us consider the process P2. Here for the process P2, two number of instances of resource A is required, but one is already allocated. So 2 minus 1, one instance of A is required. So whereas 3 instances of B and 5 instances of C are the maximum required, but they are already allocated with 3 and 5 in B and C respectively. So no more instances of B and C are required. So 3 minus 3, 0, 5 minus 5, 0. 6 instances of resource type D at the maximum required. Currently they are allocated with 4. So 6 minus 4, 2 instances of resource type D is required for the process P2. Once the need matrix is computed, we need to apply the safety algorithm to check whether the system is safe or not. We'll start with a process P0. We are comparing the need with the availability here. This is the current availability. When we are comparing the need matrix with this availability for P0, we find that P0 doesn't need any kind of instances. So we can allow P0 to continue with the task. So P0 is granted and it completes. So the available resources is 1532, which means from 1520 it gets updated to 1532. It is because looking at P0 already it has been allocated with 0012. Once the job is done, it returns the allocated resources. So with 1520 we are adding 0012. So which means the updated availability would be, when we are summing it up, it is 1532. The 1532 instances are available in A, B, C, D respectively. So this P0 is done. Moving on to P1. When we are checking P1, the need of P1 is 0750. When we compare it with the updated availability here, we can find that P1 is in need of 7 instances of B, but we have only 5 instances of B. So P1 can't be completed at present, we can't grant it. Moving on to P2. Looking at P2's need, it is 1002, whereas very well P2's request can be, we can allow P2 to continue, you can grant it. So P2 will be allowed to execute, you will provide the resources that is granted, P2 gets completed, P2 is granted, and the availability becomes 2886, which means the allocation matrix of P2 is 1354. So when we are adding this 1354 with the availability, 1354 with the availability, the new availability becomes 2 plus 4 is 6, 3 plus 5 is 8, and 5 plus 3 is 8, 1 plus 1 is 2. So this is the new availability, 2, 8, 8, 6. So P2 is completed. Check with P3. P3's need is 0020. Yes, P3 is granted now. you can provide 0020 resources for P3. P3 completes the task. So once it completes, P3 has to return this allocated resources. So your availability gets updated with this. So already availability is 2886. P3 completes and returns the task. So with 2886 we have to add 0632. So when we are adding this with the availability, the updated availability is 6 plus 2 is 8, 8 plus 3 is 11, 8 plus 6 is 14, 2 plus 0 is 2. This is the availability. Now P3 is completed. Moving on to P4. P4's need is 0642. 0642. Yes, we can grant for P4. P4 is granted. That will complete the task. P4's allocation is 0014. So when we are adding 0014 with this when we are adding 0014, 0, 0, 1, 4. When we are adding, the updated availability is 2, 14, 12, 12. 2, 14, 12, 12. So 8 plus 4 is 12, 11 plus 1 is 12, and 2, 14 remains as such. Now once again we have to check, are there any processes left out? There is one process P1 which we were not able to grant it. Now let us check for that P1. P1's need is 0750. Now upon checking the availability we find yes, P1's need can now be granted because we have enough number of resources instances in all the resource types. Now P1 is also granted. Now P1 will complete. P1's allocation is 1000. So when we are adding it with this availability 1000, the new availability becomes 3, 14, 12, 12. So this is the updated availability. So somehow or the other we are able to manage and we are able to complete all the 5 processes. So it's a safe state, and the safe sequence is P0, P2, P3, P4 and P1. Then the third question is, the question was P1 is making a request, so whether to grant it or not. So assume that request for P1 is somehow granted. We are granting the request for P1. If that is the case, from the availability you are providing the request. So the availability is 1520, and from the availability when we are taking and providing it to the P1, it becomes 1100. So which means P1 was asking for 0, 4, 2, 0. So this is the request made by P1. So what we have to do to check whether we can grant it or not is, as if we are providing it, we have to update the values, everything. We have to check whether the system is safe. If the system is safe, we can grant it. So 0420 is the request made by P1. So when we are taking 0420 from 1520, the availability is 1100. Now availability becomes available minus request. This is the request. Available becomes available minus request, and allocation becomes allocation plus request, and need becomes need minus request. That is, need of P1 is 0330. So now that gets reduced. Now continuing with the third question, yes, to check whether the request can be granted or not. So as I said, 0420 is the request made by P1. If that is the case, what we have to do is, your available becomes available minus request. So what we are going to do is, as if we have provided the request, We will update all the values and once again we will apply the safety algorithm. If the safety algorithm results in a safe state, then obviously we can grant the request, or else we should not grant the request. So let us assume that we are granting the request of P1. So if that is the case, the available was 1520. So if we are taking the resources from the availability and providing it to P1, the new availability would be 1100. Also, this 0420 will be added to this P1. 0420 will be added to this P1, which means allocation becomes allocation plus request. So 0420, which means the new allocation would be 1420 is the new allocation. If the new allocation is 1420, I am just noting it down. The allocation is 1420 and the new availability is 1100. Then the need matrix would be max minus allocation. So 1750 minus 1420 would be 0330. This is what we have learnt in the resource request algorithm. Available becomes available minus request. Allocation becomes allocation plus request. Need becomes need minus request. So you could see here from 0750 the need gets reduced to 0330 because we have already allocated, so the need gets reduced. Once these values are updated, let us proceed with the safety algorithm and we could find, yes, we are able to provide the resources to the various processes. Somehow we can find that the system is in safe state and this is the safe sequence P0, P2, P3, P4, P1. So as we are able to provide the resources to all the processes and all the processes were able to complete the task, we can conclude that the system is in safe state. As the system is in safe state, we can grant the request. Now moving on to the second problem. The second problem, we have four processes P1, P2, P3, P4 and there are two resources R1 and R2. Similar to the previous problem, we have allocation, maximum and available. There are two questions here. We need to calculate the need matrix and we have to check whether the system is safe or unsafe. The need matrix is maximum minus allocation. It is 2, 3, 1, 3, 1, 1 and 2, 0. So this is the need of the various processes. Processes P1, process P2's need is this and process P3's need is this and process P4's need is this. So once that is computed, the need is computed, we need to check whether the system is safe or unsafe. Okay, the availability is 2, 1. Let us compare each and every process need with the availability. Need of P1 is 2, 3. When we compare with the availability is R2, we have only one available, but P1 is in need of 3. So we can't proceed with P1. Moving on to P2. Again, P2 also needs 1, 3, but we don't have that many number of instances. We need 3 instances of R2, but we have only one instance of R2 in the availability. So leaving that, moving on to P3. Yes, P3 needs 1, 1. Yes, it needs 1, 1. In the available, we have 2, 1. So P3 will be granted. And P3's allocation is 1, 1. So to the availability 2, 1, when we are adding 1, 1, it becomes 3, 2. Yes, this is the updated availability now. We have to proceed with this availability. So this is completed. P3 is completed, done. And moving on to P4, need is 2, 0. Checking with the availability 3, 2. Yes, 2, 0 is sufficient. So you can grant P4. P4 is granted and the availability gets updated. The allocated resources to P4 is 3, 0. So when we are adding 3 comma 0 to this 3 comma 2. We are adding the allocated resources of P4, that is 3 comma 0 with this 3 comma 2. It becomes 6 comma 2 is the availability. So P4 is granted and the availability becomes 6 comma 2. So P3 is done, P4 is done. What are the remaining processes? Remaining processes are P1 and P2. Check P1. The need matrix is 2 comma 3 for P1, but still R2 instances we have only 2 here, but P1 is in need of 3. So again P1 can't be done now. Look at P2. Again P2 is also in need of 1 comma 3 where we have 6 comma 2. So R2 instances we have only 2 where P1 and process P2 they are in need of 3 instances. So how many times even if we are checking those processes cannot be granted, their tasks can't be done. So we can conclude that the system is in an unsafe state. Then the third problem, here we have 4 processes P1, P2, P3, P4. Two resources R1 and R2. Allocation matrix is there, maximum resources are given and the availability matrix is 1 comma 1. Let us check whether the system is safe or unsafe. First, we need to compute the need matrix. Maximum minus allocation will give the need matrix. That is computed. The next step is we need to check whether the system is safe or unsafe. Here, we are comparing the need of P1, that is 3 comma 0. We are comparing it with the availability 1 comma 1. Need of P1, we are comparing it with the availability. It's not less than or equal to, say it's false. So from P1 we move to P2. P2's need is 1 comma 1. You are comparing 1 comma 1 with the availability 1 comma 1. The condition is true. So P2 will be granted. P2 is granted and now the availability becomes 1 comma 2. Availability was 1 comma 1. As P2 completed, P2's allocation is 0 comma 1. So when we are adding 0 comma 1 with the availability, the new availability becomes 1 comma 2. Check with P3. P3's need is 0 comma 3. We are checking it with the new availability 1 comma 2. Here 3 instances of R2 are required for P3 but we have only 2 in the availability, so that's false. Proceed with the next process. So as of now we can find P2 is done, P3 is not possible, so we are moving on to P4. P4's need is 1 comma 2, 1 comma 2 and we are checking with the availability, yeah, it's 1 comma 2, it's true, so P4 is granted and the availability becomes 3 comma 2. So from 1 comma 2 it becomes 3 comma 2, that is the allocation of P4 is 2 comma 0. So when you are adding 2 comma 0 with this availability, it becomes 3 comma 2. Now P4 is also done. In the next iteration, proceed and check for P1. P1's need is 3 comma 0. The availability has updated to 3 comma 2. Now when we check, yes, the condition is true, we can continue with P1. So P1 is granted and the availability becomes 4 comma 4. Allocation of P1 1 comma 2 gets added with the availability 3 comma 2, so it becomes 4 comma 4. Now P3 is the only process that is left out. P3's need is 0 comma 3 when we are checking with the availability 4 comma 4. Yes, it's true. P3 is granted and the availability becomes 5 comma 4. Yes, we are able to complete all the 4 processes and its system is safe and the safe sequence is P2, P4, P1 and P3. P1 and P3. This is the safe sequence. Thank you.